Let's begin. Uh, Welcome everyone. This is wave motion lecture number 2, and we were discussing what we were discussing in the last class. We were discussing transverse wave in the last class. We had seen wave equation, and we had seen that this wave equation represents uh, the equation of all particles at all times. The wave equation of a progressive wave, if I just recollect, that was given by y is equal to a sine omega taken common t minus x by v, where t is the time in seconds and x is the position of the particle on the x-axis. Do we remember this? Yes or no?
Yes, sir.
Here, remember this. Here, if I put x is 0, if I put x as 0 and vary time t, then what will happen? I will get position of the particle at x is equal to 0 at all times. Do we understand this? If I put the value of x as a fixed number 0, 1, 2, 3, 4, I will get the position of the particle which is present there at all times. Now, that is case number A. Now, if I do the reverse of this, what do I mean by the reverse of this? If I put t as 0 or t as 1 second, 2 seconds, 3 seconds, and then vary x, then what will happen? Can you tell me? And I vary x, I keep that value of time fixed 0, 1, 2, 3, 4, and so on, and I change the value of x. What will I get, beta? What will I get? I will get the position of what? Position of all particles at time t is equal to 0, or I will get a snapshot or a picture of the wave at that given time. Do we understand this? Yes or no? Do we understand this? Yes or no? Do we understand this? Yes or no? You don't understand this? We don't understand this? Either we understand this or we don't understand this. It's very simple. We understand this, yes or no? That if I put the value of time fixed and vary the value of x, and I will show it in a diagram which I had shown you last day also, but I don't think that you seem to recollect. This is again a diagram taken from your sheet, and it is on page number 188. You can have a look at this diagram, and then I can explain. When I look at diagram number A, what I have done, I have put the value of x as constant. Let us say I had put the value of x as 0, and then I had varied time. So I get the displacement of the particle, which is at x is equal to 0 at all times. If I put t as 0, the value, if I put t as 0, the equation becomes y is equal to a. If I put x as 0, the value becomes the equation becomes y is equal to a sine omega t, and I get the position of that particle at all times, which is shown by this graph. Do we understand this? Great. Now if I change the scenario and I come to equation or graph B, what I have done for variable particle at a constant time. Let us say I put the value of t as 0. Let us say that I put the value of t as 0. Then what happens? At time t is equal to 0, I get the position of all particles. I get the position of all particles at that time. That means I am getting a snapshot, a picture of the wave, the equation of the wave. If I put time t as 0, and I've assumed that the equation is omega t plus kx, I've assumed that the equation is omega t plus kx, then I can write the equation as y is equal to a sine kx, a sine kx, and then I will get, remember, I have put the value of time as 0. Do we understand this? Can I have the raised hands from all of you that we understand this? I will get a snapshot, a picture of the wave. This is how the wave looks when I see it or I take the picture at any given time. So this is the thing that I wanted to tell you. Now if I keep on varying both x and both t, I will get position of all particles at all times. Do we understand this? Let us do it by a small example. Maybe you will be able to make more sense, and I shall do it so that this concept remains with you. So here I come. I hope you can see my screen. Yes or no? Let us say I have given a question. Question number 1: y is equal to 2 sine 20t minus or plus, let us say, x by 2. This is the equation of a wave given. Now, first of all, you tell me what is the amplitude of this wave. Can you tell me the amplitude of this wave? Can you tell me what is the amplitude of this wave? Let me just correct the equation. Can you tell me what is the amplitude of this wave? Can you tell me what is the amplitude of this wave? And the amplitude of this wave is 2. Do we understand this? Okay. What about the angular? Okay. What about the angular frequency of this wave? To get the angular frequency of this wave, we will compare it with the original equation, and omega will become the angular frequency. Do we understand this? A is the amplitude, as you can see. Omega is the angular frequency, and 2 becomes your speed. Yes or no? Now, if I ask you a question for a particle, at x is equal to 0, for a particle at x is equal to 0, find the position at t is equal to 0 and t is equal to 1 seconds. How will you do this? So I have a particle whose position on the x-axis is 0, x is 0. You have to find its position at t is equal to 0 and t is equal to 1. I will give you a minute to think about this question and give me the answer. I will be back in a minute. Let me help you out. How do you do it? It is given that the particle is at x is equal to 0. So what you do is, the first thing you do is, you put the value of x as 0. Do we understand this? So how do you go about solving it? You put the value of x as 0. The equation becomes y is equal to 2 sine x becomes 0, 20t. Now this equation will give you the equation of that particle at all times. At t is equal to 0, you find the value of y. Sine 0 is 0. So the value of y also becomes 0. At t equal to 1 second, you just put the value of t as 1 second. The value of y becomes 2 times sine of 20 radians. Do we understand this? So this is how I can get the position of the particle which is there at x is equal to 1 at all times. Do we understand this? Yes or no? No or yes? Great. Now, if I ask you another question, this is question number A. Now let me ask you question number B. Find the position of a particle at x is equal to 1 at time t is equal to 0 and particle at x is equal to 2 at time t is equal to 0. So what I have done here is I have kept the time same and I'm asking you the position of two particles. Can you do that for me? Okay, I'll give you time to do it. So how do you do it? It's simply, first you put the value of time as 0 in the original equation. How does the original equation look like? Y is equal to A sine 20 multiplied by k by 2, I mean x by 2. So it becomes 10x. Do we understand this? Yes or no? I've just put the value of time as 0. Now at time t is equal to 0, I can find the position of particle which is at x is equal to 1. Just put the value of x as 1. I can find the position of the particle at x is equal to 2. Just put the value of x as 2. Do we understand this? Yes or no? Well, that was the only thing. That was the only thing that you needed to understand, and this is what you have done. You have just put the value of time as 0 and you get the equation as y is equal to a sine 10x. That is it. If you do it, you are done. I hope you have understood this. Let us move forward because time doesn't wait for anyone. So let us move forward and try to wind off this chapter, this part today, and start with the next thing. Now the next thing that we are going to do is known as a standing wave, and we'll have to understand the difference between a standing wave, and a progressive wave. The equation of the wave that we have seen is a wave which is traveling. Now when the wave travels, wave moves in this direction and the particles move in this direction. Do we understand this? Because we are talking about transverse wave. Do we understand this? Wave is traveling like this. Particles are moving up and down. Great. That is a traveling wave. Energy is getting transferred from one point in space to the other point in space. Right now, what we are talking about is something known as a standing wave. What do you mean by a standing wave? A standing wave does not propagate. It does not move. It is just a standing wave. Now, how do you produce a standing wave? The simple way you can produce a standing wave, if you can superimpose, if you can superimpose if you can superimpose one wave traveling in this direction with the other wave traveling, opposite wave traveling in the opposite direction, and both having a phase difference of 180 degrees. Do we understand this? They must have same omega, they must have same frequency, they must be traveling in the opposite direction, and they must have a phase difference of how much? 180 degrees. That means if one wave has got crashed, the other wave must get do we understand this? Yes or no? So when we have this thing happening, we'll have something which is known as a standing wave. So if I have a wave which is moving, remember when there is a negative sign, this means that this wave is moving in positive x-axis. Do we understand this? Yes or no? Great. This wave is a wave moving in the positive x-axis. I hope you can see this. Now we have another wave. Everything is same. The only thing is it is moving in the negative x-axis. Do we see this? Yes or no? Great. Now, what we have done, and I'm just showing it to you on your sheet, I have created a phase difference of pi. Do we see this? A phase difference of pi. I have created a phase difference of pi between the two ends. And how do I create a phase difference of pi between the two ends? I get the wave reflected from a denser medium. Do you remember when the wave is going from rarer medium to denser medium, it gets reflected with a phase angle of pi? If this happens and these two waves superimpose, remember sine of 180 plus theta is minus sine theta, and therefore we have a minus sign over here. Do we understand this? Yes or no? No or yes? Well done. If that happens, then you will have, then you will have, then you will have two waves which are moving in the opposite direction, same omega, same frequency, but differing by a phase angle of pi. And the result when they superimpose, is a standing wave. And this is how they superimpose. This is how they superimpose on each other. When they superimpose, we just add y1 with y2. Do we remember this? Do we understand this? This is my wave number 1. This is my wave number 2. And they are superimposing. So basically, I take everything common. And this is a simple formula of sine A minus sine B. And I just put the trigonometric formula there. With which trigonometric formula we are putting sine C minus sine D or sine A minus sine B, whatever. We put this trigonometric formula. This is cos C plus D by 2 into cos C minus D by 2. And this is the formula that you get. This is the equation of a standing wave. Do we understand this? What are the important things that you must remember about the standing wave? First, they are formed by superimposition of two waves moving in opposite direction. Two waves in opposite direction. Number two, the waves must have same amplitude, same omega, same frequency, same time period. Do we understand this? Number three, they must be having a phase difference of pi. Do we understand this? Number four, if you look at this term, this is the amplitude of the standing wave, and as you can see, This amplitude is two times. This amplitude is two times of the original wave. So remember, amplitude of the standing wave is two times of A. Can you remember this? Can you remember this? Remember, then there are two things that you must remember. I'll give you a minute here to write this down first. Now, there are two things that you must understand here. The two things that you must understand here. In the equation of this standing wave, if I put the value of x as 0, the value of y becomes 0. Do we see this? Where x is 0, y is 0. Here the displacement of the particle will always be 0. The particle will not be displaced at all. It will just remain there. These points are known as node. A node means a position where the displacement of the particle is 0. Can you remember it? Node. Please note down node. And this node in this case happens where x is equal to 0. Now, if there is a position where x is 0, there will also be a position where x is maximum. And the maximum value of displacement is 2L, 2A. Do we understand this? And the maximum value of displacement, when I put the value of x as L, I will get the displacement of the particle as 2 times of A. Here the particles have maximum amplitude, maximum displacement. These points are known as antinodes. Can you remember this? Nodes and antinodes for standing waves. Nodes and antinodes for standing waves. Nodes are the point where the displacement is 0. Antinodes are the point where the displacement is maximum. Do we understand this? Yes or no? We'll talk more about standing waves in the next topic, which is longitudinal waves. We'll come back to this again. Up till now, this much is clear that standing waves, how are they formed? Two waves, same amplitude, same frequency, same time period, but moving in the opposite direction. Yes or no? No or yes? Okay, I'll give you a minute and then we will move further. Just note down nodes and antinodes. So we'll be noting down some important points on standing waves or stationary waves. These are the points which are not given there. So please note down what is the first point. What is a standing wave? When two sets of progressive waves, where they can be longitudinal, they can be transverse, doesn't matter, having the same amplitude and same time period, traveling with the same speed in the same straight line in opposite direction superimposed, the wave which is formed is known as a standing wave. Do we understand this? This is the complete definition which covers everything, every aspect of standing waves. I would ask you to write this. This is not from your sheet. I would ask you to write this. Do we understand this? They must be having same amplitude, same time period, traveling with the same speed, same medium in the same straight line, but in opposite direction. These are the things that you must remember about standing waves. Can I move further ahead? What are the properties of standing? Okay, writing. I'll give you time. Now we write certain characteristics of standing waves. Each and every characteristic of a standing wave is important. So please write them down very carefully. This is a standing wave. It is not moving. It is not a progressive wave. So this disturbance is confined in a particular region. It has a starting point. It has a reflecting point in it. And it is only between these 2 points. It is not moving in the medium. Do we understand this? Point number 2, similar point in a different way. There is no forward motion of the distribution of the disturbance. This wave is not traveling, it is just in its own place. The total energy associated with the standing wave is twice the energy of each of the wave. Similarly, the amplitude is also 2 times of the amplitude of the constituent waves. But remember, there is no flow or transfer of energy. The energy does not get transferred. Do we understand this? There will be points whose disturbance who are permanently at rest. These points are nodes. Remember, between two consecutive nodes, if I have one node and if I have second node, between two consecutive nodes, the distance would be lambda by 2. Do we understand this? Yes or no? No or yes? Similarly, we will have points of maximum amplitude. These are known as antinodes. Between two antinodes, the distance is lambda by 2. Between one node and the adjacent antinode, the distance will be lambda by 4. Please write these points very, very carefully. I'll give you time. Let's move ahead and see the next points. There are 2 or 3 points first that I would like to explain, and then I will move. The next point that you are going to write is the medium splits itself into a number of segments. Each segment is vibrating up and down as one entire system. I will show you those systems. You just note this down. All particles in a particular segment vibrate in the same phase. Particle in two consecutive phases differ by two consecutive segments differ by a phase of 180 degrees. Now you might be confused. Are what is happening here? What are these phases? Don't worry. Just note down these 2 points. Point number 6 and 7, and meanwhile I will show you what segments am I talking about, and I will show you this diagram in wherein I would show you a couple of segments, and then I would try to make some sense out of it. Do you see this, bacha? Do you see this on your boards? Right, as you can see, in diagram number 1, I see how many segments? I see 2 segments. Yes or no? This is segment number 1 and this is segment number 2. Do we understand this? So this segment number 1 is vibrating together and this segment number 2 is vibrating together. Do we understand this? In segment number 1, all particles are in the same phase. In segment number 2, again, all particles are in the same phase. But if I look at segment 1 and segment 2, they are 180 degree out of phase. That means when the particle is here in segment number 1, in segment number 2, the particle would be here. So they will differ by a phase of pi from one segment to the other segment. Here in the second diagram, I see 3 segments. Particle in one segment are oscillating in the same phase. Particle in the second segment are oscillating in the same phase. Particle in the third segment are oscillating in the same phase. The only difference is between phase number 1 and phase number 2, they differ by a phase angle of pi. Between 2 and 3, they again differ by a phase angle of pi. Do we understand this? Yes or no? No or yes? So this is the diagram that I wanted to show you to explain what was given here in point number 6 and point number 7. Now we will move ahead into the next point and then I will give you time to note this down. So point number 6 and point number 7 is done. All the particles which apart from nodes, because node does not move, execute simple harmonic motion about their mean position, same time period. The amplitude of vibration varies from 0 to maximum at antinodes. Twice during each vibration, all particles will pass simultaneously through their mean position. The wavelength and time period of stationary wave is same as that of the component wave, but the amplitude is twice. Do we remember this? Yes or no? No or yes? When the particle pass through their mean position, they have maximum velocity when they are at their antinode position, and it is 0 when the particles are at their node wala position. In standing wave, the amplitude of component waves are, if they are not equal, if they are equal, the amplitude of the node will be 0. If they are not equal, the amplitude at nodes will not be 0, and therefore some energy will pass. To have 0 energy passing, both the amplitudes must be same. Do we understand this? All these points. I'll give you 2 minutes to note down these points. Question will come based on what you have understood from these points. 2 minutes, and I will be back. Please note it down, beta. Okay, then the next setting that you will write is the vibration of a string, and you must write the formula for fundamental frequency, the first frequency, F. If you write the frequency as F, this F is 1 by 2L root over T by M. Remember what is the meaning of the terms that are appearing here. L is the length of the string, T is the tension in the string, M is the mass per unit length. We call it linear mass density. This is the formula for frequency of a standing wave that is created in a string. This is the diagram of that standing wave, and this is the fundamental frequency or fundamental node of this standing wave. Remember the formula. Questions come based on this formula. I'll give you a minute to note it down. Are you noting it down, beta? We have seen the formula for frequency of a standing wave produced in a string. These are the laws that you must remember. We have seen the formula of frequency is 1 by 2L root over T by M. So comes the first law, which is known as the law of length. Frequency F or N is inversely proportional to length. N1 by N2 will be L2 by L1. If T, tension and mass per unit length are constant, do we understand this? The second formula is law of tension. Frequency is inversely proportional, is directly proportional to root over tension. Remember, length and mass are constant. Law of mass, frequency is inversely proportional to mass per unit length. The root F1 by F2 will be equal to root over M2 by M1. Remember here, length and the tension in the string are constant. Please note, very important formula here because questions come repeatedly on this concept. Law of length, law of tension, and law of mass. Are you noting it down, beta? Please note it. Well, we have seen the basic formula for frequency 1 by 2L root over T by M. That was the formula for fundamental frequency. We had only one loop. If we had P number of loops, 1 segment, 2 segment, 3 segment, I told you about that segments. If I have 2 segments, the value of P is 2. If I have 3 segments, the value of P is 3. Do we understand this? P is the number of loops here. Now, this is the formula that we have just seen, but this formula can be written in various forms. This is the next form in which you can write it in terms of density and the radius of the wire. In the second case, you can write the formula in terms of density as well as the radius of the wire, and therefore we can form the law of radius of frequency. Remember, questions have come repeatedly on this. Frequency F is inversely proportional to the radius, as you can see here. You can see here or not? Here, density L and T are constant. Do we understand this? This T here has been replaced by mg here. Sometimes we hang a mass to create this tension. Therefore, this tension is equal to mg. Do we understand this? The next formula is law of density. You can see density comes in the denominator. So frequency is inversely proportional to root over d, or f1 by f2 will be equal to root over d2 by d1. The rest of the things are constant. I will give you a minute to note it down. If you have any doubts, please come forward and ask. We move to the most important part and the most lovable part that I do, and this is to solve some question and answer. You can open your sheets, and that is page number 197 of your sheet. Question number 1. We will be discussing the entire theory and a quick revision of transverse wave. And here we go with the first question. What the first question is: the property of a medium which is necessary for the propagation of wave, for the wave to move forward. What are the properties needed? Number 1, inertia, elasticity, resistance. Number D, all of the above. You have the exercise sheet, yes or no? Then tell me the answer for this one. This will be a quick revision. If you can do this question, fatafat, that means transverse wave is done. What is the answer for this one? The answer for this one is for all of the above. We need inertia so that energy, they can carry energy. If they don't have inertia, they cannot carry energy. We need elasticity because they need to come back to their original positions. If they don't come back, that's a problem. They must have low resistance, otherwise a lot of energy will be lost in the process. Do we understand it? Yes or no? No or yes? Well done. That takes us to the second question, and we'll be dealing them one by one, one by one. And this is the second one coming on your screen right now. And I'm waiting for your answer. Water waves are A, B, C, D. Waves that are produced on water are what? Well, we have seen that the surface waves of water are transverse in nature, but when you see an actual wave in water, it is the particles are oscillating like this, as well as the particles are oscillating in the same direction. Therefore, it's a combination of longitudinal and transverse wave. Do we understand this? Yes or no? No, yes. So that is the answer. This is the next question. We have not covered it in theory. So you just should remember the formula. What is the relation between particle velocity? When I say particle velocity, this is the velocity of any particle at any time. Particles are oscillating up and down, whereas the wave is moving in the forward direction. V is the wave velocity here. Remember, U is the particle velocity here. Please remember. And the relation we have not discussed. I don't know whether you know it or not. We have not discussed, but you will just remember this formula. Particle velocity U is minus V dy by dx, where U is the particle velocity, V is the wave velocity, dy by dx is the derivative of y with respect to s. Can you remember this for me? Yes or no? No, yes. That was question number 9. Let me move on to the next one. And again, it is a simple formula based question. These are the type of question that is going to come in the exam. And this is question number 10. Which of the following is not a formula for wave velocity? V is equal to omega by k, V is equal to f lambda, V is equal to 2 pi by tk, V is equal to k by omega. Let me see who can give me the answer for this one. K, remember, is 2 pi by lambda. Which of the following is not? Yes, well done. This is, I was not expecting this, but this is good. The formula number 4 is the wrong formula. Well done, bacha. That means you understand the wave equation and you understand its basic formulas. Comes the next one. By which of the following waves energy is not carried? Which are the waves that does not carry energy? And the answer is a straightforward one here. No prizes for guessing. A stationary wave is the wave that does not carry energy. We all know this. We all know this. Now comes the time where we're going to do two questions at the same time. Question number 4 and question number 5 here. Coming to you right away. Which of the following are longitudinal waves is the first one. Question number 4. Which of the following are longitudinal waves? Sound waves. Yes. As soon as we have sound waves, there is no point of going any further. The next point is stationary waves. Tang, 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 tang. Energy is. Option number 2 is not transferred. It's a stationary wave. The name suggests that energy is not transferred. Comes the next one. Comes the next one. Comes the next one. Question number 6. Let me have the answer for this one. The wavelength of sound wave in a gas. You have not seen the formula for sound wave, but don't worry, you will be able to tell me sound wave is a longitudinal wave, and I've told you what is the wavelength of a longitudinal wave or a transversal wave. Which one is the answer? 3 is the distance between two particles which are in the two consecutive particles which are in the same phase. You can also call it as the distance traveled by the wave, not in 1 second. Distance traveled by the wave in 1 second is wave speed. Distance traveled by the wave in one time period is your wave velocity. Do we understand this? Yes or no? No or yes? Well done, bacha. I am really getting very excited that you have understood these simple things, because these are the things that are going to make a difference in the final result. Comes the next one, and I'm hoping for an answer here too. The propagation of sound waves is not possible through A, B, C, D. And the answer is vacuum. They are mechanical waves. They need particle mediums. If there are no particle mediums, the wave cannot transfer, the wave cannot be formed, and therefore the answer is vacuum. You cannot create a sound wave in vacuum. That means when you go on moon, if you become an astronaut, you have to speak through comms. Your voice will not travel. Do we understand this? Yes or no? No, yes. Comes the next one. The diagram, the phase difference between points A and D is A and D, A and D. Path difference is given as X. To find out the phase difference, can I have your answers? Remember, we had already done that. Yes or no? No, yes. Path difference and phase difference. The X, the value of X which is given over here is the path difference. 2 pi by lambda into X. Kajal, do we understand this? Yes or no? No, yes. Here comes the next one, which is based on the equation of a wave. We have to do some questions based on the equation. The displacement of medium in a sound wave. Remember, sound wave or transverse wave, the equation is same. Y is equal to A cos AX plus BT. Capital A, small a and small b are positive constant. Then the wavelength and the frequency of the wave is. I'll give you a minute to think about it. Well, how are you going to do this? Remember, you will have to equate it to an equation which looks like this. We have the answer. Yes, 4 is the answer. Are you looking from the answer sheet and telling me the answer? Remember, here if I equate it to the wave equation, the value of k becomes equal to A and the value of omega becomes equal to B. Remember, k is 2 pi by lambda. So lambda becomes 2 pi by A. Omega is 2 pi f. So f becomes omega by 2 pi, and therefore the correct option is option D. Do we understand this? Yes or no? No or yes? Well done. Then here comes one more based on the wave equation. The equation of a progressive wave moving in the positive x direction. The sum of the formulas given. You just have to find out which is the correct one. The formula may look very confusing, but if you remember the basic concept, the formula should be easy. One of the options is definitely wrong. This is definitely wrong. Yes or no? No or yes? But it is plus. So don't have to think about this. Then you have to look at which option is correct. All the options are looking similar, but you can put some brain and let me know which is the correct option. Which one is the correct? A, B, C, D. You can look at the dimension and probably tell me the answer. Which has the correct dimension, because all of them are having different dimensions. Looking at the dimension, you can tell me the correct answer, and the correct answer is C. Do we understand this? This is another way of writing the wave equation. I told you, if you remember 2 or 3 ways of writing the wave equation, you should be doing good. Do we understand this? Yes or no? Well done. We'll do 1 or 2 more questions, and then we will move on to the next topic. This is the next one based on simple concept. If the frequency of a wave is 100 hertz, then the particle of the medium cross the mean position how many times in 1 second? That is the question. And what is the answer? Whether they cross 100 times, 200, 400, or 50? How many times they will cross their mean position? And the answer is, in 1 cycle, they cross 2 times. They will have 100 cycles, so they will cross it 200 times. That is absolutely clear. One more question based on wave equation, and probably then we will call it a day for this chapter. This one, I'm showing you more and more equations on waves, so that any one of those equations would come, and at that time you should not be caught. Which is not the correct equation? Question number 26 is what we have in store. Which one is the correct equation? Which one is not the correct equation? All the equations are looking similar. But one equation, if you look at the dimension is gone all over the place. And which one is that? Remember, if you get such a question, you can, even if you don't remember the equation, you can solve it by dimension. There's one equation whose dimension is not correct, and that would be your correct answer, because that cannot be the equation of a progressive wave, and the answer is D. Do we understand this? Yes or no? No or yes? Well done. Well, the remaining question I would leave for you to solve while you go back home today. And with this, we come to an end of this part of wave motion, in which we have done transverse wave. What are transverse wave? Wave is propagating like this, particle moving up and down. We have seen the equation of a progressive wave. We have also seen equation of standing waves. At node, the displacement is 0. At antinode, the displacement is maximum. I'll give you 5 minutes now, and you can go through the entire chapter of transverse wave. We'll start with the longitudinal wave in the next lecture. So please go through it. I will be back. Take care.